Okay, very good afternoon, everyone. This is the Geotechnical Engineering 2 class, and we are in the week 4 of this coursework. This coursework is taken by Professor D.N. Singh sir from IIT Bombay. My name is Sumit Kumar. I am PhD research scholar at IIT ISM Dhanbad. And during this session, I am taking this coursework, and this is my second time when I am taking this coursework only. So I have a earlier experience of teaching as well. So I think my experience of teaching these subjects or providing insights about the thing which has been gone across during this coursework will be helpful for you. Okay, so now we will start the today coursework. As the you know, in the previous 3 weeks we have studied many things about the shear strength. So in this week we will move further in that direction and we will cover some more points. So first of all, I will take the first 5 minutes to recap the last class in a very brief, just by moving slide by slide at what we have covered, and afterwards I will start with the new content. I think so that will be okay for everyone. So, and one more instruction I want to add on over here, as some of you may be unaware of, that if the content which I am teaching over here will be shared with you with the Google Drive link. Apart from that, in addition to that, you will also got this lecture in the YouTube, as I am recording this and I will upload in the YouTube. Those who are not over here or maybe watching on the YouTube can come later and go through these lectures. This will be helpful for you. And addition to that, one more point is like if due to any network issue, if my connection goes out, so please be remain in the meeting. I will rejoin the meeting and start the class from there only. And this coursework, as you know, is taking place from 3 to 5 every week on Saturday. So if you are available on that time, you can attend in the live as well as afterward, because I want to keep the session interacting. But as it has been seen that the not many people are turned out during this session, so it's maybe the problem like you have the other commitment during that time, so you are watching on the YouTube. So that's not the problem for me. But if any problem is there, you can ask me in a class, or maybe you can ask me at the forums which are provided to you to ask the question. I will happy to answer your queries. Okay. So with this, I will start the today's session. So this is the fourth week of the geotechnical engineering class. First of all, I will take the quick recap of the last class and then move ahead with the new contents. And one more thing I want to add on, that during this session, up to this session, we have covered many problems as well. So I will suggest you to solve those problems and also go along with the similar type of problem from the following class, not today. From the following class, that is from the week 5 class, we are mostly concentrating on the solving problems more often as compared to theoretical content, because that will help you more in a more better way. Up to here, there is the more theoretical concept is there that will be help in solving the problem. So I try to cover those things during the last entire session. Apart from that, in the last session and last to last session, that is week 3 and week 2, we have solved many problems. But in the from week 5, the problem concentration is must increase much as what we have seen during the last 3 weeks classes. Okay, so we will go ahead with that. First of all, I will recap the session of the last session, that what we have read, and then we will move with the new content. Okay, so first of all, you see, we have understand the definition of shear strength, that what is the shear strength means to us. Afterwards, we come to understand that what are the factors which help in which contribute in the cohesion, that is the contribute in the providing the shear strength, that is the cohesion and angle of internal friction. Afterward, that we come that what type of tests are there, so we come to know that the direct shear test, triaxial test are there. In the direct shear test, what are the failure mechanism is there, we also come to understand the importance of the shear strength. The geotechnical engineering is understood by us. And in addition to that, we understood that how in the granular soil and in the cohesive soil, the strength is helpful for us in one way or the other. So what do we mean by that? that in how cohesion provides shear strength and how the granules while the angle of internal friction help in contributing in a strength that is understood by our in the last sessions. So these are the two slides. After that, we understood the shear failures, in which we come to understand that the about state of stresses like the sigma and tau is there. Afterwards, we come to understand that the parent body detached body concepts, in which we have also seen that after the applying a certain amount of force or certain amount of load, the failure planes get achieved, and the detached body, the body which are in the concentration with the parent body get detached out. So that the top critical concept is also understood by us. So the physical example is also shown. I am just taking the quick revision that those concepts will be revised in your mind that what we have gone across during the previous classes. So from here when I put the new things, the revision will be there. This revision need to be done by you as well before coming to the class, but just as a small revision session, like in the 5 minutes, I will try to show you all the slides that those things will be revised in your mind. So we will go ahead. So these things you have understood, that detached body and parent body concept, and how, we also understand that how if the strength of the failure surface, that is the critical failure surface, is suppose 100 unit, the up to the load applied up to 99 unit is totally acceptable, but when the load apply 100 unit, it is on the verge of failure, and when the load is the 100.1 unit, the surface get flow out. So that concept we have discussed. So you must have understood those things. We understand the triaxial state of stress. We understand that we are doing the two dimension, that is the sigma x, sigma z, and how we found the shear stress and the normal stress. What are the different normal axis and shear axis, and the principal shear stress and principal shear strain is understood by us. And in the Mohr circle, we found the properties of Mohr circle, sign convention about the Mohr circle, and we also come across the how we can found the origin radius and principal shear stress and principal shear strength. We also saw some problems during the first class. After that, its application, what application should be there in the civil engineering is covered during the that sessions, and the applications, how it is practically implemented in the field. And apart from that, some more problems is taken over here. We are able to found that at a specific angle, what will be the maximum principal stress and maximum principal strain. So those things we have covered during our previous sessions. Okay. So now I will, apart from that, we have understood the Mohr Coulomb failure criteria. So from here we will move ahead and we will cover the new content from here, and go one by one in our today's session. Okay. So now I will start with the new things, because whatever thing I want to show you is already covered. Now we will start with the new content that will be more helpful for you over here. So I will also take a pen. Okay. So in today's class, first of all, we will start with the exploring the triaxial testing in the geotechnical engineering. As you have seen earlier, we have discussed about the direct shear test as well, vane shear test, triaxial test, but in we have run more in detail about that. We just say that the three type of triaxial test is there. That is the UU test, CU test, CD test. That means we have come across those things, but we will now discuss in detail, like unconfined unconsolidated test, consolidated drain test, consolidated undrained test. That is CU/CD. Okay, I think so. Those things we have discussed. So we will go ahead with that in the today's session, and you will understand, get the better understanding of the things. Okay, so first of all, see, we start with the definition again, because the basics should always there before we moving ahead. So first of all, we talk about the definition. What is shear strength mean to us? So when we define a shear strength as a material response when subjected to the shear motion. Basically, it has been actually do the thing when the stress is applied, the strength resist that force, and that will only provide a mechanism in which the soil is resisting the failure up to a certain strength, up to a certain unit of force and stresses. That is the shear strength of the soil, and it is the concept of shearing motion and detachment along the plane. And we have shown those concept of a weak plane as we see. If there is a soil body anywhere across, if you suppose if you are sitting on a table and chair, and you suppose the height of table as a soil mass. The height of table is as a soil mass, and that is a part of a road embankment. Now, suppose a situation that due to maybe heavy rain or due to some seismic activity, there is a failure takes place across those sections. So, how the failure takes place? If when you are sitting on a table and you are considering the whole as a soil mass, so it may be the chances that it fails from the one corner or the other. It may be chances that the large part from the middle section of the table get detached out. So there must be a specific lane from which the soil flow out. It's not the case. So when we are talking about the critical shear strength, so that part where the soil is in the most weak zone from where the failure takes place, so that plane is said to be weak plane, and the critical shear strength of that section of that soil section is said to be that value only, because if we consider any other value, if we suppose when we talk about a soil mass, now let's take an example. Suppose this is a specific soil section. There is a very small soil section. Now, if you see, this is a standard part, but if suppose this cross section is the soil only, so the soil may be weak over here, may be very strong over here. So the failure takes place from this section only. But if we consider this section only for the our test or analysis, so when the we concentrate on these sections, so the strength over here will be more. So we state that the strength of this soil is that much, but it may fail at some other section. So that problem is when we talk about the critical. Critical is means that plane which is the weakest plane in our in our soil section. So from where the failure takes place, so that section is the weakest plane, and the stress at which that failure takes place is the critical stress. Okay, now we talk about the factors which influence the theory. So the major factors are the one of the major factor is the earthquake. That earthquake can lead to relative motion between the soil particle, as we know. When we talk about the seismic activity or the earthquake, one thing come in everyone mind that during the earthquake, during the seismic tremors, the soil particles come into movement with respect to one another. So there is a motion takes place between the soil particles or the soil layer. If the stratified soil layer is there, there is a different type of movement could be there. So and in general, when we see the condition of water, soil types, if it is the sandy soil, maybe sometimes liquefaction can take place during the seismic tremor. So those things are there. So the readjustment, removement of soil particle between each other could lead to the relative movement and could lead to the failure of soil from that section. Another is, uh, as we know, the fault is there. So the fault can cause one portion of ground to slip down, leading to the shearing. As the soil sections, there are several faults are there, and the movement could be up and down, or maybe this section. If you have gone across any course of the earthquake engineering, or the geotechnical earthquake engineering, so yeah, or soil dynamics, over there you will come across those things like how the failure takes place, how the subsidence takes place between the plates or and the parts move over one another. So this is one of the cases. As of now, we just you just understand that a fault causing one portion of ground to slip down, leading to the shearing. And when we talk about the understanding of state of stress during the shearing, is one of the most crucial thing for the stability assessment, because the stability could not be achieved if we could not able to understand the state of stress during that time only. Okay, now we talk about the other factors. So the other factors that could cause is like the slope instability. Slope instability is always there. In slopes we see the failure are there. Earlier, last year you have seen in the Josimut, the subsidence taking place and the structures are getting damaged over there. You also come across the several news of the landslides takes place, especially in our northeast regions, in the mountainous regions. So those are the other factors over where we are able to see that the soil gets failed out, and sometimes some construction activities also lead to the failure of the soil. So these are the some of the most important factors. When we talk about applications, there must be some application when we are talking about these things, and its significance should also be there. So the engineering significance of understanding the shear strength in the geotechnical projects and the shear strength analysis help the design is designing foundation retaining walls and slopes, because as you know, if we does not know the strength at any places, whether we are able to construct anything over there, because the strength need to be known before any construction work is going on, because on the basis of that only we are able to say that this much load could be sustained by this soil structure. Excuse me. Okay, so what aspects I want to say over here, like suppose any construction work, suppose over here as it has been mentioned that retaining wall, maybe some retaining wall are constructed for the road constructions, as maybe the soil need to be sustained between those places. So you need to understand what strength of soil will be there. If some road construction work is going on, so there must be some strength of that soil, as you have known about the soil improvement techniques. So why soil improvement technique is needed? If the all soil are of good strength to sustain the specific amount of load, so if any construction work, like suppose road construction only, road construction is going on, and first of all we take the test of the soil at the specific site where the construction is need to be done. So when the test is performed over there, it comes to know that this much load it can sustain. After what we say that what type of vehicles is moving over there, whether it is a highway or a normal village road. So on the basis of that, what strength is needed. So if it satisfies that criteria that this much strength is needed for the transmission for the transmission of vehicle over there, so it will be said that okay, if this much needed and this is sustained, so no problem, just after providing the proper test the construction work is going on over there. But if it has been found no that the soil property is not that much acceptable for the construction of road work over there, so one need to do some important things. And what is that important thing? That they need to improve the characteristics of soil by the various techniques of the soil improvement. Afterwards, again the test is performed whether the achieve we achieve that much strength that is required. Afterwards, the construction takes place. Now, suppose in the example we doesn't do so and we construct the road. So over there, what problem could arise? We see that the road get damaged in a very less time, because the soil strength at some place may be relatively more or some place may be relatively less. So subsidence takes place as the heavy vehicles move over there. There is a due to that load, the at some place load at some place due to those loads, the soil gets subsidized and the road are not uniform. So the road strength get reduced. So it is the most important aspect that one need to understand, that the strength need to be checked before doing any construction works, so that our structure get its long life. Okay, now we talk about the role of shear strength is most important in assessing the stability of natural and man-made structure, because the human activity like construction and expansion can alter the state of stress in soil. We say na, we have understood the sensitivity in the last class. We say sensitivity equal to undisturbed shear strength by the moderate shear strength. During the Venn shear test, after the Venn shear test slide, we come to know about the sensitivity. So, due to human activity, soil gets alter its property sometimes or the other. Specifically, when we talk about the state of stress, we are not talking about the material property. We are talking about the state of stress. So, due to which also the strength get affected, as I have said earlier, that during the various ground improvement techniques, we are able to improve the characteristics of soils. So it is obvious that we could able to achieve the different state of stress due to the construction work. So that thing need to be understood. Now, when we say that the incremental changes in stress can lead to the shearing, especially along the weak places, yes, obvious. During our last slides discussion, we come across this fact and we have said that this failure could be developed. Okay, now we talk about the Mohr-Coulomb failure criteria. That what is the Mohr-Coulomb failure criteria? When the soil has failed, the shear stress on the failure plane defines the shear strength of the soil. Thus, it is necessary to identify the failure plane, that is the plane on which the maximum shear stress acts, or it is a plane where the ratio of shear stress to normal stress is maximum, because by which we are able to find the critical plane of failure, and at present it can be assumed that the failure plane exists and it is possibly to apply the principal stress and measure them in the laboratory by conducting the triaxial test. Because as I have discussed earlier as well, in the triaxial test we are able to achieve the practical situation what is over there in the field, so that condition is justified. Okay. Now, when we talk about some more points in the Mohr-Coulomb failure criteria, we come across that the Mohr circle of the stress at failure for the sample can be drawn using the known values of principal stress, and if the data from the several tests carried out on a different sample up to the failure plane is available, a series of Mohr circle can be plotted. As we have seen that when we draw the series of Mohr circle and draw a common tangent, we found the failure envelope as well. So it is convenient to show only the upper half of the Mohr circle because it is the symmetry about the x-axis. A line tangential to Mohr circle can be drawn and called as Mohr-Coulomb failure envelope. When we talk about the Mohr-Coulomb failure envelope, when we say, if anyone say Mohr-Coulomb failure envelope, any understanding need to become in our mind? Yes, obviously. So what understanding will be there? The understanding in our mind that the failure envelope is drawn and the stress below that failure envelope is applied, there is no failure takes place. But if the state of stress touches that failure envelope, the failure is obvious from that section. Okay, I think so. Up to this, there will be no confusion in anyone's mind, and I will again add one more points over there, that if you are going through the YouTube lectures, if you are any doubt, you can ask me questions in the comment section over there as well. I will happy to answer you, as because there are less people there, so interactive session what I expected, which we have done during the last session, is not possible this time at up to this lecture. So you can ask over there, the interaction will be there, and if any doubt remains, you can come in the next class, you can ask the question, and I will happy to answer. Okay, I will move ahead. Okay, so as what we have discussed, that we will draw the Mohr circle at the different state of stress, like the we keep changing the sigma, we keep changing first of all the sigma 3, and for that sigma 1 will be found. After that, this in the when we say second set of Mohr circle, we change the sigma 3, the value of sigma 1 also get altered. At third stage, we again change the sigma 3, we again get the value of sigma 1. Afterward, we draw a tangent which touches all the three Mohr circle, and that tangent is the Mohr circle failure envelope, and the state of stress below which is the up to that the failure doesn't take place, but when the state of stress moves above that line, the failure takes place. Okay, there will be no doubt in anyone mindset from this. Ah, yeah. Again, over here you can see the picture clearly. Like you see, first of all, sigma 3 dash 1 is applied and corresponding sigma 1 dash is found. Similarly, sigma 3 dash 2 and sigma 1 dash 2 is found. And sigma 3 dash 3, sigma 3 dash 1, sigma 1 dash 3 is found. And similarly, the fourth more circle is drawn, then a common tangent is drawn. And one more point could be captured from here, that the intercept on the y-axis, that is the axis, is the cohesion, and the angle with the horizontal axis, that is the sigma axis, is the angle of internal friction, which we could able to found through this drawing the Mohr Coulomb failure in Vela. Okay, I think so. Over here there will be no doubt. Yeah, I think so. Okay, hello. Yes. Okay. So now we will talk about some more point in the Mohr Coulomb failure criteria, that if the stress condition of any other soil sample is represented by a Mohr circle that lies below the failure envelope, every plane within the sample experiences a shear stress which is similar than the shear strength of the sample. Thus, the point of tangency of the envelope to the Mohr circle at failure gives a clue to the determination of the inclination of the failure plane. And when we see in the triaxial test how these things actually implemented. So when we talk about the triaxial test, we say it is a 3D depletion of the stress of the material, as we have said in many times. It replicates the practical 3D situation in the field to the laboratory. It offers the better replication of in situ stress conditions and helps in understanding the soil behavior under the more complex loading conditions. And how it takes place, we will see. So, in a triaxial test is carried out in a cell of cylindrical soil sample having a length to dia ratio 2. What do we mean by that? Length is 2 times the diameter. Like you see, when we talk about the usual sizes are the 76 mm into 38 mm. Over here you can see 76 mm is the length and 38 mm is the diameter. So the length is 2 times the diameter and the other is 100 mm into 15 mm. It also satisfies the L by D equal to 2 criteria. Okay, now when we talk about the three principal stresses are applied on the soil sample, out of which two are applied by the water pressure inside the confining cell and are equal. Okay, when we talk about this point, we have discussed as well, which is not written earlier, but I have stated many times that suppose okay. Suppose this is a cylindrical sample. You can see. Okay. Yeah, I think so. Up now in on this cylindrical sample, when the state of stress is applied by my hands, it's applied from the all parts, all directions very equally. Okay. Okay. So when the state of stress are applied equally, that will be like if you consider the x direction and z direction. So in the x and z direction, the state of stress are applied through the waters that is confining in a confining cell, that is the confining pressure, and that will be equal. And the stress in the normal direction is applied is in the is of different value, that is said to be deviated stress as well, we will come across. Okay, not to worry. See, okay, Okay. Okay. So the three principal stresses are applied onto the soil sample, out of which two are applied water pressure inside the confining cell and are equal, and the third principal stress is applied by a loading ramp through the top of the cell and is different to the other two principal stress. Yeah, obviously, what I have said earlier. And the typical tri-cell cell you can see in our next slide. Over here, you can see that the deviating stress is applied from the upper section, the water is filled in the cross section, and that apply the confining stress, that is the sigma 3. And over there, you can see the cell pressure, pore water pressure, back pressure, the volume change, everything could be measured. So, how this test perform and what are the results we come across, we will see that and we will move ahead with that. Okay, so we talk about the first of all test procedure. Okay, so give me a minute. I will take some water. Okay, okay, no problem. So we are talking about the test procedure. So first of all, a soil sample is placed inside a rubber sheet which is sealed on the top, sealed to a top cap and bottom pedestal by the rubber O-ring. For test with the pore pressure measurement, porous discs are placed at the bottom and sometimes at the top of the specimen. And why this porous? We have discussed earlier as well. We will come across it. Okay, and a filter paper drain may be provided around the outside of the specimen in order to speed up the consolidation process. The paper help in that, and the pore pressure generated inside the specimen during the test can be measured by the means of pressure transducer. So, first of all, we say when we talk about the triaxial testing, it's a fundamental and the powerful technique in the geotechnical engineering. Why fundamental and how powerful we will see. It will help in understanding the soil behavior and determining the shear strength parameter. So, in over here during this presentation, we will see the detail of the tri-excel testing, that is its setup, the types of test. When we say the types of test, that is the UU test, CU test, and CD test, and the parameters which we are able to obtain, that is the C and phi, and how we will develop the relation is like the sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. So over here you can see that in the triaxial compression test consists of the two stages. First stage is said to be consolidation stage. In this, a soil sample is set in a triaxial cell and a confining pressure is then applied over there. In the second stage, the additional axial stress, also called as the deviated stress, that is nothing but the sigma 1 minus sigma 3, we will come across that, is applied, which includes the shear stress in the sample. The axial stress is continuously increased until the sample fails. You have seen the Coulomb failure curve over there. You have also seen the sigma 1 sigma 3 is plotted. So over there the sigma 3 is applied, after that the deviated stress is applied from the upward direction up to the failure takes place. At failure, what will be the value of sigma d is found, and sigma d is the sigma 1 minus sigma 3, so we are able to find the sigma 1, and on the basis of that we are able to draw the Mohr circle, and afterward in the next setup we again increase the sigma 3 value to sigma 3 2, and again apply the deviated stress. In that case also we are able to find the plane at the deviated stress at which the soil gets filled, and we are able to find sigma d2, and sigma 1 2 minus sigma 3 2 is the sigma d2. So we are able to find the sigma 1 2 sigma 3 2. Again in the third case we rectify the same implementation, and at that situation we are able to found the three or four Mohr circle. Then we draw a common tangent and we are able to form the Mohr Coulomb failure envelope. Okay, so we are talking about in the second stage. The additional axial stress, also called as the deviated stress, is applied, which includes the shear stress in the sample, and the axial stress is continuously increased until the soil sample gets filled. So during the both the stages, the applied stress, axial strain, and the pore water pressure, or the change in the sample value can be measured. As we have seen, this is the limitation in the direct shear test. We are not able to find those things over there. We also seen that the failure plane is predefined there, so that is also one of the factor, that is some other plane is the weakest plane, so we are not able to found that. But over here everything could be able to measure, that even the volume change, the pore water pressure, applied stress, acceleration, everything we are able to find out. So the total stress and the effective stress analysis could be performed easily without any problem. Okay. Okay, so over here when we talk about the first stage schematic representation, you can see in the first stage all round cell pressure is applied with the help of water. Water is filled over there. That is the confining pressure is applied, and in the second stage the deviatic stress is applied in addition to the confining stress. And during the different condition, the valve, that is the water may be flowing out or not, will be evaluated on the basis of that the pore water pressure and the volume change can also be specified. We will discuss about those things, but as of now you can see that in the stage 1 the stress from the all direction is same, that is in the stage 1 all round cell pressure with the help of water. In the stage 2, in the addition of the all round cell pressure, the deviatic stress is applied in the axial direction, and on the basis of that we are able to find the, with the help of the matrix we are able to find the sigma moment value. And so for the different soil condition, like the cohesive or cohesionless, we are able to find the soil parameters. Over here you can see one more image. Over here you can see a piston which has been seen in the top of the figure is used to apply the dielectric stress, and O-ring which we talked about in the test setup during previous 2 3 slides is also shown. The impervious membrane is shown in which the soil material is prepared to apply the confining pressure. The porous stone at the top and bottom is also seen, and the whole section is filled with the water. And you can see the pore pressure or the volume change measurement could also we can take place. The cell pressure and the back pressure is also shown over here, and the pedestal on which it stands is also represented. So the overall triaxial test schematic diagram is shown over here, with the help of which you can develop a test understanding. Okay, now when we talk about the understanding the triaxial test, so the purpose is to evaluate the shear strength parameter of the soil sample. Purpose is that only, that we are able to evaluate the shear strength parameter. And when we talk about the shear strength parameter, what are the shear strength parameter? Shear strength parameter are the cohesion and angle of internal friction. Yes, yes. Okay, so the sample collection. So exact cylindrical samples from the field will be collected, and it will be filled in the membrane and then kept in the setup which has been shown in the last slides. After that, in the setup, a sample mounted on the porous stone sandwich between each loading base plates, everything will be placed out and the test is performed. Okay, now we see the types of triaxial test. So first is the CD test, like the consolidated trend test. Nothing is first or second. The different type of test we are discussing about is named over here. Then the CU test is there, like the consolidated untrend test. Then the UU test, that is an unconsolidated untrend test, set to fastest test. And afterward UCS test is also there, over in which the unconfined compression strength test is said. Okay, now we will discuss one by one the definition of each test. Over there, first of all, starting with the UU test, that is the unconsolidated untrained test. In this, the cell pressure is applied without allowing the drainage. That's clear from the name only, unconsolidated undrained. So the water pressure is not allowed to flow out, and keeping the cell pressure constant, the Beatrix stress is applied. Like first of all, the cell pressure is set up and all valves are remain closed. After that, the cell pressure is applied, the Beatrix test we are going to apply, and all the valves remain closed. That is, the no water is allowed to flow out. The stress is increased at which the soil gets filled. Without the water to be flow out, that all valves remain closed. So over there, the no drainage is allowed, so the volume remain also constant during the entire test. And in the UU test, we one more additional point we could capture is like no section. So this test also takes place quickly. And when we talk about the practical implementation, it replicate in one way or the other the clay condition in which the water flow out takes much larger time. So that also replicate that condition. Okay. Now we talk about the consolidated undrained test. What is the consolidated undrained test? So in this, drainage is allowed during the cell pressure. Everything is clear from the name only. As we have first of all unconsolidated undrained test, water is not drainage is not allowed in the first condition and second condition as well. Over here we are saying consolidated undrained test. So during the first stage, like the confining stage, drainage is allowed. Afterward the drains are get closed. So in this, the drainage is allowed during the cell pressure application, and then without allowing the further drainage, the deviating stress is increased, keeping the cell pressure constant. Because when we close the valve, the cell pressure become constant during the consolidation stage, and the water is not allowed to flow out during the deviated stage. Then we come across the consolidated trend test. This replicates the real field condition for sand. So this is similar to CU test. Expect that during the deviating stress increase, the drainage is permitted. So over here we are able to find the effective stress parameter very easily in the direct first approach. So the drainage is permitted and the rate of loading must be slow enough to ensure the no excess pore water pressure get developed, because if that happens, the result replicating those conditions is different from the real condition. That's why that thing need to be taken care of. Okay. Now we talk about the pore water pressure measurement. So before we move to those part, we will take a small break. We will come at 4:1 to start the. We will start the session after the 5 minute break. So the 5 minute break will be there. Okay, we will meet in 5 minutes. Please remain in the meeting who are over here, and we will start in 5 minutes. Hello. Hello, welcome back everyone. Okay, I think so. I am audible. Right. Okay, so we will move in the session ahead. I think so. Up to here, you are enjoying the lecture. So after this small break, we will move with the contents. Okay. See. So before we have lived, we are talked about the three of the test. Yes. So what are those tests? Those tests are UU test, CU test, and CD test. Now we are talking about the poor water pressure. That how the poor water pressure measurement takes place. So, okay, before going in that detail, we first of all talk about its importance, the measurement setup, and then we talk move further in that direction. Okay, see. So when we first talk about the poor water pressure measurement, so there must be importance. Yeah, the importance is obviously there because we have talked this as a limitation of the direct air test. So it help in understanding the influence of poor water pressure and the valve used to apply the back pressure or the measure the pore water pressure we have seen in the triaxial setup which I have shown through the schematic diagram in some slide earlier. Okay, and it impact the consolidation undrained and the consolidated undrained test in one way or the other. That is CU test and UU test. Okay, the parameters which has been analyzed is like the shear strength parameter, that is the cohesion and angle of internal friction. Triaxial test offer the comprehensive insight into the soil behavior. When we talk about its implication, so it derived the parameters crucial for the geotechnical design because we already know the cohesion, angle of internal friction, after the soil property like the basic soil property density, void ratio, cohesion ratio, porosity, different things. And these are the most important parameters which will help in understanding the shear strength of the soil. Okay. See, so when we talk about when we move further, we see the significance of triaxial testing. That is, when we saw, say, it is one of the Brahmas in the geotechnical engineering. That is a vital and irreplaceable technique because it is one of that technique which will surely come across to give us a understanding about the fact that the value of the shear strength is at how much extent we have achieved after the different applications of the ground improvement as well and early and before that so. And it provides a holistic view of the soil property under the different conditions and it is the fundamental for the accurate design and construction. So we see, yeah, but it is a little bit lengthy process, time consuming process, and sometimes it also needs some special laboratory persons to do so. So that's why at some point of time people doesn't prefer this test and they go with some other test instead this. But this is one of the tests that give the pure field conditions. It replicate the field condition in one way or the other. Okay. Yes, sir. Yes. Okay. Now we talk about significance. The first stage simulates the laboratory that in situ condition that the soil at the different depth is subjected to the different effective stress. Yes, when we talk about the confining stress, what it's replicate. Suppose a condition, you must be over there in your room at this point of time, or maybe sitting on the table or chair, or maybe on the bed. You see, you consider a section of the table in front of you as a soil section. That is, the soil is filled from the bottom floor up to the height of the table, and that is the purely original soil section. Just imagine. Now, by when you imagine a spherical section. Uh, 90 centimeter or maybe 50 centimeter below the table, there is a soil section on which the stress is applied all round from the adjacent soil section, so that stress will be constant at this point of time. That condition satisfies the first stage condition, that is the confining stage condition. And the consolidation will occur if the pore water pressure which develops upon the application of confining pressure is allowed to dissipate. Otherwise, the effective stress on the soil is the confining pressure or the total stress finding the pore water pressure which exists in the soil. This is a common sense. We have discussed about the total stress, effective stress orally, not in the presentation. During the second class only over there I have stated in a very detail, but over here I will just say that total stress is nothing but it is the sum of the effective stress and the pore water pressure. So over here that is written the pore water pressure is sorry, effective stress is the total stress minus pore water pressure. So that's not the difference. Okay, during the shearing process, the soil sample experiences the axial strain and either volume change or the development of the pore water pressure occurs. Yes, surely. And the magnitude of shear stress acting on the different planes in the soil sample is different, and at some same strain, the sample face, the limiting shear stress on the failure plane is called to be the shear stress. Yeah, surely. I think so. This point will be very much clear in everyone's mind because I have discussed again and again in different with the help of different examples. Okay, now see, when we recap the previous section, we say that the triaxial testing stands as a con, as in a geotechnical engineering, offering a profound insight into the shear strength parameter of the soil, that is the CN5, and by performing the different tests of the triaxial test and incorporating the pore water pressure measurement, engineers gain a comprehensive understanding of the soil behavior. This understanding is crucial for making the informed decision in the geotechnical designs and the construction projects. The triaxial testing remains a timeless and essential tool that continue to shape the field of geotechnical engineering. Obviously, because this test is irreplaceable, because this test present the every condition of the soil section. By performing that, we are able to find the exact field condition. So this is irreplaceable in after many years as well. Okay, so over here we will close our triaxial test setup conditions and the different type of triaxial. Now we see advanced insight in the triaxial testing technique and what is that we will go across from here as we move forward. Okay, see, so first of all, starting with the triaxial testing has evaluated significantly over time, transiting from the traditional method involving mercury column to the modern electronic system. Yes, obviously, you have seen the triaxial setup. If you see the old setup, that will be based on the different conditions of that which is discussing, and in the modern system the electronic system also came across with the help of computers. The results are replicating over there with times. Basically, when you see some dynamic tests could also be performed in that type of systems. And in this presentation, And the complexity of tri-cell testing, including the sample preparation, corrections, and the drainage consideration, will be there. When we talk about the evaluation of this system, so earlier method involves the mercury column for the pore pressure application and measurement. In modern time, the technology introduced the electronic pressure sensors and transducer for the measurement of the pore water pressure. So, with the evolution of technique, this tri-cell test setup get little bit changed, and the calculation is more accurate. And as the sensors are there, so the result are replicating in the real time. So the value of the stress or strength which we are confining from this, which we executing from this test, is found to be 100% accurate. You see, when we talk about the test setup components, so the first of all, the confining stress is there, that is the sigma 3 or the sigma c using the water filled cell. In the first stage of the stress, when we talk about the load frame, the modern motor controlled frame or the uniform shear stress, that is we have seen in the schematic diagram, the normal stress is applied from the upward direction. A plunger and a probing ring O-ring we have said earlier is there in the schematic diagram. So the transfer load to the sample and measure the applied stresses. When we talk about the porous stone, we have talked about the papers which are implemented over there that ensures the controlled drainage condition, because the stones are also there on the upside and downside of our soil samples. When we talk about the setup, it is a cylindrical soil sample extracted from the field. Typically, it has been seen that the 78 into 38 mm and 100 mm into 50 mm is there, where the 100 is the length and 50 is the diameter. So that is the twice the length is twice the diameter is over there in the sample length. And when we talk about the set of components, the mountain on a porous stone enclosed by a rubber membrane. The soil is enclosed in the rubber membrane on which the confining pressure is applied through water. When we talk about the loading plates, applied the axial stress by the steel plate and the probing ring that is applied implemented in the top. And the deformation measurement is also takes place with the help of the dial gauge tracks volumetric deformation. Okay, so up to here I think so everything will be clear. Okay. See, when we talk about some of the correction factors like the rubber membrane correction, the rubber membrane is there in which the soil sample is created. So the rubber membrane effect on the soil strength and the deformation is also there. And when we talk about the shear strength correction, the correcting for the higher axial strength due to the membrane also could be there. And the compensating for the axial strain caused by the composite samples. When we talk about the composite samples, the sample is implemented with the help of porous stones over there also. So the axial strain may also get affected due to that also. So that correction will be there. Now, when we talk about the radial drainage system, that is in the radial drainage consideration, simulating the three-dimensional consolidation with the radial drainage. In this method, a filter paper with the silt around the sample, enabling the radial drainage. And the when we talk about the Bishop and Haeckel approach, in their approach, the depth guidance on a correction method for drainage condition is implemented. And as we recap this section, we say that the triaxial testing has transformed from the traditional mercury-based method to the advanced electronics techniques. Rigorous correction factors like we have seen for the axial as well as the radial, and for the membrane to everything is applied for the rubber membrane to the shear strength to the axial strength are the crucial for the accurate result. As I have said earlier also, when we are developing our technology, we are getting advancement our technology, we are able to achieve the more accurate solution and the more real situations. So our the parameters of the strength which we are able to achieve it through the test which we are able to find through the test is the more accurate. and the radial drainage simulation and its calculation. Further, refine the testing process. So the comprehensive understanding of these ensures the higher quality of reliable triaxial testing outcomes. Okay, now we are talking about the consolidated drainage triaxial testing and it's some of the interests. Okay, so see what we are going to see from here. Okay, whether my slide is visible. Okay, let me check by myself for a while. Let me check. Okay, yeah, it's visible. I have seen by myself. Okay, so we will move ahead. As we are talking about the triaxial test, is a comprehensive geotechnical engineering allowing the evaluation of soil property under the various loading and the drainage conditions. This In this presentation, the complexity of the consolidated drainage triaxial testing will be discussed from here, in which the membrane correction, radial drainage, and the concentration characteristics and the upper bounds will be discussed. So first of all, we discussed about the membrane properties and the corrections. So the membrane elastically affect the test outcome. Obviously, as the its elasticity also affect the test outcome because that will not be there in the actual field condition. The soils are adjacent by the soil particles only, but not by any membrane or the medium. So that's must also affect. And so, what are the process for the correction? So, deduct the membrane effect from the shear strength and the axial strength measurement, as well as the membrane introduction adds elasticity, influencing strain and shear strength. When we simulate a 3D condition with the radial drainage, we see in the when you consider the 3D consolidation consideration, radial Radial drainage simulates the three-dimensional consolidation. So method is that the sorry method is that the filter paper with the silt encases the sample, enabling the radial water percolations. The sort it shortens the drainage path, accelerates the consolidation process. So in this manner process takes place. When we talk about the consolidation characteristics in a CD test philosophy, first of all understanding the material behavior with the no remaining volumetric moisture. Afterwards, the hydrostatic condition sigma 3 pressure and the no shear stress condition is achieved. And the time dependent the volumetric deformation changes with time due to the consolidation is considered. When we going to calculate the CV value, the coefficient of consolidation, it is obtained from the time to constant volume state. The benefit which we get from the CV test that the value of CV, that is the accurate value of CV under the all round pressure, that is not unlike the one dimensional test. When we talk about the loading conditions, so the drained conditions due to the poor water pressure dissipation. When we talk about the embankment analogy, the gradual poor water pressure dissipations during the embankment construction. Variation of strength, when we talk about that, the upper bound of material strength obtained in the CD test, as it has been discussed during this section's first slide only. When we talk about the upper bound and lower bound in the geotechnical engineering perspective, seeking the upper and the lower bound for the material strength that we are talking about, and the ultimate strength, when we talk about the ultimate strength, the CD test provide the upper bound on the material property. The practical significance of that is the critical in the limit equilibrium and the plasticity theory studies. When we recap this section, we come to know that the consolidation drain triaxial testing provides the valuable insight into the soil behavior, accounting for the membrane effects and the radial drainage, consolidation characteristics, and the strength bonds. Understanding these intricates enhances the geotechnical analysis and design, contributing to the safer and the more efficient engineering solutions. Okay, I think so. The things are getting clear. Now we will move in exploring UUCUCD triaxial test for the geotechnical analysis. Okay, okay, so we'll go one by one with the help of the different test results. Okay, so give me a minute. Okay, excuse me for a minute. I will come. Hello everyone. There is some problem over here due to which I have to take a small break. Yes, yes. Okay. See, hello. Yes, I am audible. Okay, no problem. I will move ahead from here. Let me check something that whether recording is going on or not. Yes, it's okay. See, we are talking about the upper bond and lower bond. So in the geotech, I think so we have moved across, no? Yes. We are talking about exploring the UUCUCD triaxial test for the geotechnical engineering analysis. So we are over here now. Okay, then? Okay. So first of all, we are talking about the UU test. In UU test, we see that the over here you can see first of all sigma 3 is applied and the corresponding sigma 1 is found. Afterward, sigma 3 gets changed and the corresponding sigma 1 is also found. So in this condition, what takes place? There is no drainage allowed in the first and second stage as well. So the no volume change takes place. So after doing so, when we draw a condition, so as I have said very earlier that the UU test most importantly replicate the clay condition because over there also the water is not allowed to flow out because the water flowing out takes lots of time over there. So this replicate that condition only. So over here, if it is performed on the clay soil, so the phi must be zero. The cohesion intercept is only found. So the over here with the test result, when we draw the three Mohr circle and a common tangent to get drawn, the value of cohesion is found. CU is represented and the phi u is found to be zero. But this condition at the different test get also got changed. We will discuss about that moving ahead. So here the all Mohr circle for the UU test plotted in the term of total stress, not the effective stress. Yeah. Have the same diameter and the failure envelope in a horizontal straight line, hence the phi UU is going to be 0. Yes, right? And the it can be represented by the equation tau f equal to CUU equal to sigma 1 minus sigma 3 by 2. Now when we talk about the CU and CD test for the total stress condition, over here when we draw the sigma 3 sigma 1 and sigma 3 sigma 1 again and draw a tangent, over here CUU and CCD is not found to be same. Similarly, the phi CU and phi CD is not found to be same. What are those conditions? Because of the drainage condition in Euro test, the no drainage is allowed in during the both stage, but in the CU and CD test, CU and CD test, in CU test, first of all, in the first condition, the water is allowed to flow out. In the CD test, the water is allowed to flow out in the both conditions. So that is the effective stress condition get found out. Okay, so we will see that for the test involving the drainage in the first stage, when the Mohr circle are plotted in the term of the total stress, the diameter increases with the confining pressure. Now, when the resulting in the failure envelope is an inclined line with the intercept on the vertical axis, it is also observed that the CCU, that is the cohesion in the consolidated and drain test, and the cohesion in the consolidated drain test not found to be equal. Why? Because in the consolidated drain test, water is allowed to flow out in the both conditions, so the effective stress condition get developed. But in the CU test, during the first stage, the water is allowed to flow out, but in the second stage, water is not allowed to flow out. So that condition doesn't replicate the CD test condition. That's why the angle of internal friction and the cohesion is not found to be same during the both stages. It can be stated that for the identical soil samples tested under the different axial conditions of the UU, CU, and CD test, the failure envelope is not unique, but when we move ahead and we do the effective stress parameter analysis, over here we are able to find for the all the tested the results replicate the similar condition. We will come across that and see over here. Sorry. Yes. Right. See, so if the same triaxial test result of the UU, CU and CD test are plotted in terms of the effective stress, taking into the consideration of the measurement of the pore water pressure, it is observed that all the Mohr circle at the failure are tangent to the same failure envelope, indicating the shear strength is a unique function of the effective stress on a failure plane. So over here we can see the failure envelope get formed in that fashion, and C dash and phi dash is the effective shear strength parameter, that is the C dash and phi dash. And when we see the failure envelope in the shear strength envelope, which may then be written as tau equal to C dash plus sigma dash and phi, where C dash is the cohesion intercept in term of the effective stress, and phi dash is the angle of shearing resistance in term of effective stress only if sigma and dash is the effective stress acting on the rupture plane at failure. Tau n is the shear stress on the same plane and is therefore the shear strength. We have come across this during our earlier session as well. So the understanding of these things will be not very difficult for any one of you, I think so. Yes. See, so we will move ahead and we see our interrelation, our famous interrelation, which interrelate the C sigma 1 and sigma 3 as sigma 1 dash equal to sigma 3 dash into 1 plus sin phi by 1 minus sin phi plus 2c root under 1 minus 1 plus sin phi by 1 minus sin phi. This interrelation I have stated many times in the different fashion as sigma 1 dash equal to sigma 3 dash tan 45 plus sigma 3 dash tan 45 plus 5 by 2 dash for 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. So this is similar. When you do the trigonometric calculations, we are able to find that, and that's not any big thing. Okay. Now, when we talk about the triaxial testing methods such as the consolidated drain and the consolidated undrained test that offer the valuable insight into the soil behavior under the different loading and the drainage condition, we have come across that as well. So, during this presentation, we delivered the principal application and significance of these tests for accessing the geotechnical stability. So, what we are talking about? We are talking about the effective stress analysis. So, in the effective stress analysis, pore water pressure measurement takes place, and during this, that when the drain condition is there, the result in the zero pore water pressure during the consolidation and the slow shearing takes place. The effective stress parameter, that is the effective stress analysis, yield the parameter applicable to the effective stress condition. When we talk about the Mohr Coulomb failure envelope, the effective Mohr Coulomb failure envelope superimposes on the conventional envelope due to the zero pore water pressure. Because when we talk about the zero pore water pressure condition, we are actually talking about the effective stress condition only. That's why the Mohr Coulomb failure envelope for the effective Mohr Coulomb failure envelope superimposes the conventional envelope due to the zero pore water pressure. And as we see of the application for of the CD test, so it takes place, its application in the stability analysis is we found very often that it is ideal for accessing the long-term stability because in the consolidated drain test, the water is allowed to drain out during the both stages, during the stage 1 that is the consolidation stage and during the stage 2 that is the confining diametric stage. So it is ideal for accessing the long-term stability of the structures like the dam and construction of the extended period. Similarly, for the seepage and stability analysis, as in the CD test, the drainage is allowed, so the CD test aid in analyzing the downstream dam flows affected by the seepage forces and the pore water pressure changes. When we talk about the application of CU test, we come across the in the CU test simulates the rapid loading conditions such as the earthquake or the fast construction. And when we talk about its application in the unconsolidation behavior, so the study of the response in the cases where the consolidation does not occur within the material lifetime. So you see over here what are the two conditions gets developed. First, you can see in the CU test, as in the first stage, um, water is allowed to drain out, and in the second stage water is not allowed to drain out, so it's very rapid loading conditions. It help like in the earthquake or the fast construction process. It's replicated condition only. When we talk about one of the case study for the foundation construction, so in the real world scenario, foundation construction in a context of a rapid building erection and the time that is the initial consolidation due to the self-weight, rapid construction minimizes the consolidation in one way or the other. When we recap this session, we say that the CD and CU triaxial test offer the powerful tools for understanding the soil behavior under the different loadings and drainage conditions. By providing insights into the effective stress parameter and addressing the stability in the various scenarios, these tests contribute to the safer and more accurate geotechnical engineering practices as we move ahead with the under getting the development of the understanding of the CUU and UU triaxial test for the geotechnical analysis. We see that in the triaxial testing methods includes the consolidated undrained and the unconsolidated undrained test offer the valuable insight into the soil behavior under the different loading and the drainage condition. We have come across this in the many times, and during this work, during this presentation, the principal application and the significance of these tests are accessed for the geotechnical stability. As we see, shearing test in the CU test, shearing in the CU test. So what we are talking about, the CU test simulates the realistic condition. As we have, sorry, as we have seen or said many a times that the triaxial test only replicate the real field condition. So over here, the what statement say that the CU test simulates the real world scenario where the consolidation has occurred, but the rapid loading takes place. And when we talk about the deviatric stress, the application of the deviatric stress help reduces shearing after the consolidation. And in the effective stress analysis, the effective stress parameter such as the shear strength and the deviator stress play one of the crucial role in CU testing. When we talk about the significance of the A parameter that we are talked about, so A parameter, like the when we talk about A and B is capital pore water pressure parameter, so represent the effective efficiency of pore water pressure development for the given sigma 3. And when we talk about the relation to the pore water pressure, the pore water pressure, that is UD, is determined by multiplying A with sigma 3. The effective stress calculation, a parameter help in calculating the effective stress component, that is the sigma dash and the sigma 3 dash during the CU testing. And the parameter obtained from the CU test, so the CCU and the phi CU is the CCU is the subscript over here and phi CU is the subscript again. So the parameter acquired from the CU test represent the consolidated undrained cohesion and the angle of internal friction during the same testing conditions. Okay, I think so. Everything, all the things are okay with everyone. Yes, I think so. So you see effects on the Mohr circle. So Mohr circle shift during the CO test, Mohr circle shift left due to the poor water pressure, reflecting the effective stress envelope. When we talk about the possibility of the negative UD, under the certain condition UD might be negative, causing the Mohr circle to shift right. As when we talk about the pre-consolidation pressure, that the pre-consolidation pressure represent the maximum past pressure experienced by the soil to its current, that in the prehistoric time if it is loaded with what much pressure and what pressure it has been applied today is the pre-consolidation ratio or the pre-consolidation pressure. So its role in geotechnical analysis help in understanding the pre-consolidation pressure aids in accessing the soil strength and behavior, as if the soil is accessed with a large amount of load during the previous time, so it can be suspect that up to that much load there will be no failure, that in the prehistoric time that much load it sustains very easily. So if the pre-consolidated state, if the pre-consolidation ratio is more than 1, so that soil is considered to be good for the construction in general. Other soil aspects are also there, the strength is also calculated, but in general it is said it is good to go. So that's only a simple point. Okay. Now, when we recap this section, we say that the CU and UU triaxial test provides valuable insight into the soil behavior under the different loading conditions. By studying the response to the shearing and the pore water pressure, engineers can make informed decision like the good decision or the productive decision about the stability and the designing parameters contributing to the safer and the more effective geotechnical practices. When we move ahead, we talk about the pre-consolidation pressure and the shear strength behavior in the geotechnical engineering. Over here, we see, okay, over here we see, excuse me, yes. So over here we talk about the concept of pre-consolidation pressure and its impact on soil behavior. What I have said earlier also some points, but over here we will see it is written in the presentation. So it's play a vital role in understanding the shear strength variations. Over here in this presentation, the significance of the pre-concentration pressure and its relationship to the shear strength in develop is established. And when we talk about the pre-consolidation pressure, the definition and significance, pre-consolidation pressure is the maximum historical pressure the soil has experienced before its current state. When we talk about the influence on the soil behavior, pre-consolidation pressure affects how soil respond to the loading and unloading, leading to the various pore water pressure. Because when we talk about the pre-consolidation ratio or the pressure, it is applied in the past to the present. When we talk about the ratio, so if it is applied in the past, so we talk about when we talk about the influence on the soil behavior, and we see the last line of the presentation, that is the pre-concentration pressure affect how soil respond to the loading and unloading. Because the unloading takes place, that's why the stress applied in the past is more as what it is applied. If you take one of the example, we can say suppose some construction work is get established on a site, and due to some reason or the other, like it doesn't fulfill the accurate bylaws, it get demolished. So, and after maybe 20 year or 30 year, again this field is allotted for the construction. So over there, when we say that in past, in the several construction is already established which can sustain this much of load. So the pre-consolidation pressure at that site will be more than earlier. This is one of the examples. Some other example could also be taken place due to different conditions, or maybe in the drainage or some other conditions. The soil gets loaded and then flow out from over there. So those conditions can also lead to the pre-concentration pressure. Okay, when we talk about the variation in the pore water pressure, we say the positive pore water pressure, the soil with the pre-consolidation pressure less than the current stress exits a positive pore water pressure. When we talk about the negative pore water pressure, when the current stress is less than the pre-consolidation pressure, the soil exhibits negative pore water pressure. Yeah, sure. I think so that will be very clear when we go across the geotechnical engineering course, that is the basic geotechnical engineering, as we are in the geotechnical engineering too. So we are talking over here about the advanced aspects which we are not, like the implementation application what we have read in the basic soil mechanics of the soil mechanics one or the geotechnical engineering one. Okay, when we talk about the pre-consolidation pressure classification, so the normal consolidation NC the soil with the positive pore water pressure due to the pre-consolidation exhibit the frictional behavior, that is phi equal to 0, C equal to 0, and we talk about the over-consolidation soil with the negative pore pressure due to the pre-consolidation exhibit the cohesive behavior, that is C is not equal to 0 and phi is equal to 0, sure, because the cohesive behavior, so the angle of internal friction is 0. Okay, and in the transition zone, the between the NC and OC behavior represent an average both condition, that is the C5 condition. Yes, over here you can see the diagram representing the deviating stress variation with the axial strain and the volumetric change in the sample with the help of axial strain for the CD triaxial test. So over here you can see for the loose sand, the axial strain get increased with the deviating stress in the progressive manner, but in the for the dense sand, it's get increased up to a certain limit. After get it is going to be decreased for the dense sand. And for similarly, when we see the volumetric change, first of all, the compression takes place in the dense sand, then the expansion takes place. But in the loose sand or the NC soil, the value is only compressed and going in the one direction only. So these variation could be absorbed for the CD triaxial test, and this is one of the most important diagram or the graph, which if you have gone through the several competitive exam like the GATES or engineering services or the state services exam, the question could frame from the over here. You can see that how the NC clay or the OC clay behave dense and loose and behave for the derivative stress variation with the axial strain and the volumetric change of the sample with the axial strain is discussed over there. So this is one of the most important aspects which I think you could get a better understanding from here. Now we talk about the undrained shear strength, that is undrained shear strength curve rotate by the 90 degree from a shear strength envelope. When we talk about the relationship with the pre-concentration pressure, the SU is twice the undrained cohesion, that is 2C, and its behavior is influenced by the pre-consolidation pressure. Surely. And when we talk about the practical implementation, sorry. So the discretization zone will be there. Natural deposits often exceed a discretization zone due to the trying of the top soil layer. When we talk about the engineering consideration, the understanding OC behavior is crucial in the engineering project, especially in the marine environment and the coastal areas. Yes. And when we sum up this section, we say that the pre-consolidation pressure plays a pivotal role in determining the soil behavior and the shear strength variation. Recognizing the influence of the pre-consolidation pressure helps engineers to make an informed decision regarding the design stability and the construction in the various geotechnical scenarios. Yes. Now we move ahead to our triaxial testing and soil behavior analysis, that is the pre-consolidation, shear strength and testing strategy. When we move in this, we say that the triaxial testing provides a valuable insight to the soil behavior under the different stress condition. In this presentation, the pre-consolidation pressure, shear strength behavior and its significance of the various triaxial tests in the geotechnical analysis is discussed. Over here, you can see that tau equal to C plus sigma tan phi or tau dash equal to C dash plus sigma dash tan phi, and sigma d is a sigma 1 minus sigma 3, that is sigma 1 equal to sigma 3 plus sigma d. So during the triaxial testing, the sigma 3 is applied, sigma d is applied, that is in the x direction, and on the basis of that sigma 1 is we are able to found. And when we plot the sigma 3 and sigma 1 as the Mohr circle, by varying the different sigma 3, the sigma 1 and sigma 3 get plotted, and a common tangent is drawn, and the tangent drawn to the all the Mohr circle give result in the development of the Mohr Coulomb failure envelope. Yes, right? Okay, no problem. Now we talk about the pre-consolidation pressure and its implications. So we talk about the first of all starting with the definition and its importance. The pre-consolidation pressure represents the soil historical maximum stress. Its influence current behavior including the pore water pressure condition. When we talk about the positive pore water pressure, the soil stress is less than the pre-consolidation pressure, result in the positive pore water pressure. When we talk about the negative pore water pressure, the soil stress is more than the pre-consolidation pressure, lead to the negative pore water pressure. When we classify these, we say that the normal consolidation exhibits positive pore water pressure while the overall consolidation display the negative pore water pressure, right? And when we talk about the shear strength envelope and the pre-consolidation, we say during the undrained shear strength analysis, the defined as the twice the undrained cohesion. We say C equal to S by 2 or S equal to 2C, influenced by the pre-consolidation pressure, right? And the pore water pressure classification and C material lead to the frictional behavior as phi equal to 0 and c is equal to 0, sorry, phi is not equal to 0, c equal to 0, while for the OC material, which has been shown from the graph in the last slide, so the cohesive behavior c is not equal to 0 and phi equal to 0. The practical implementation, we talk about the pre-consolidation pressure influences shear strength envelope and the soil response, right? Okay. Now we talk about the unconsolidated undrained test. In UU test purpose, the purpose of UU test to analyze the unconsolidated untrained behavior suitable for the saturated young offshore materials, as we have seen that it is one of the fastest test and the process takes place very quickly. And when we talk about the untrained total stress, UU test focuses on the total stress parameter, that is phi u equal to 0 and cu equal to 0, and the shear strength envelope UU response form a horizontal line on the tau sigma plane due to phi u equal to 0. Now when we talk about the effective stress envelope, by subtracting the pore water pressure, the effective stress envelope is obtained. As we say in the triaxial test, the pore water gate pressure, the pore water measurement is possible with very easy. So it is not a big deal to find the value of the effective stress, and the development of the effective stress envelope is not a very big problem. When we talk about the UCS test and the triaxial testing, in the unconfined shear strength test, it reveals the negative pore water pressure due to lack of confinement. When we talk about the comprehensive analysis, the tri-cell testing strategizes CDCUUU provides a complete understanding of the soil behavior, interpolation, and extrapolations. When we interpolate CDCUUU test result help us in establishing a range of soil parameters for the practical use. And as we see, when we recap this section, we say that triaxial testing plays a crucial role in comprehending soil behavior, including the pre-consolidation pressure effects and the shear strength responses. The proper interaction of the test result empowers engineer to make the informed decision for the geotechnical projects, ensuring the stability and safety in the construction and design. Right. Now we move to our next section, in which we are going to discuss about the analysis of the triaxial test result, implementation of the material behavior and the test condition. And this is going to the last session, or maybe section, or the second last section before we end our today discussion. There is too much left as well, but I think so time is getting over, so we will sum up in some time. Okay, see, okay. So we are talking about the analysis of the triaxial test result, its implications of the material behavior and the test condition. So when we are talking about this, we are understanding the behavior of soil through the triaxial testing requires careful consideration of the test conditions and results. In this presentation, we are discussing the example problem involving the saturated sand specimen subjected to the triaxial testing and highlighting the significance of interpreting the test result. As we say, in the initial test setup and the consolidation, the saturated sand dimension 75 mm length, that is 7.5 mm dia, and when the cell pressure is 75 kilonewton per meter square at the initial consolidation stage, the specimen consolidated under the 75 kilonewton per meter square cell pressure. As in the shearing stress, the cell pressure raised to the 550 kilonewton per meter square for the shearing stage. For the undrained test conducted, the delta L mm decreases in the sample length during the shearing. Proving ring reading indicates the shear stress sigma D and the axial strain epsilon A. The pore water pressure monitored during the test. When we talk about the interpretations and we see that the specimen responses as shearing progresses, providing a ring reading and the axial strain change. Implications of the probing ring reading provides the ring reading top value reflect the shear stress sigma D when we talk about the axial strain calculations, the delta L by L yield axial strain epsilon A, which is equal to epsilon B for the undrained test. When we talk about the volume change, the undrained test simplifies the VI equal to VF, that is the no volume change takes place, and the pore water pressure variation correlates with the volume changes. The key observations which are found from here is uh, unlike the drain test, and drain test have the constant initial and the final volume. So because in the undrained test the water is not allowed to flow out, so the volume remains constant throughout the test, and in the pore water pressure measurement the variation reflect the volume changes due to the undrained condition. And uh, because if it goes into the pore water pressure, uh, measurement takes place over there, and A1 equal to Li by Li minus delta L into A, and A1 equal to, that is, if we convert divide the above and below by length, we found A1 equal to A by 1 minus epsilon A. See, as we have discussed this earlier, now you can correlate with this condition. Over there, you can see sigma df for the loose sand NC clay and for the dense sand OC clay. Similarly, for the change in volume, as we have said earlier. And with this, we recap this section with this fact that interpreting the triaxial test result demands a meticulous attention to the detail. By recognizing the clues like the volume evidence and the pore water pressure variations, engineers can accurately diagnose the soil behavior, addressing the inconsistent and making informed design decisions. The example underscores the critical connection between the test condition and the result and the real world application in the geotechnical engineering. As we move ahead, we see the triaxial testing, understanding the material behavior and interpolation. We say the triaxial testing is a crucial tool in the geotechnical engineering to understand the soil behavior under the different conditions. In this presentation, a case study involving the triaxial testing on the saturated sand specimen, highlighting the insights and the gain through the test result and their implementations. Over here, we see in the searing and the pore water pressure, the decreasing the pore water pressure, notable observation like the pore water pressure decreases as the searing progress, implicates the undrained test. In the unexpected behavior in the undrained test, usually water pressure rises. And when we talk about the material behavior, the recognizing the significance of the decreasing pore water pressure. When we talk about the volume change, the initial and the final volume evidence for the undrained test, initial and the final volume are same. Volume corrections factor applied to the area to the account for the volume changes. Probing ring at the shear stress correction, probing ring reading represent the shear stress sigma d as the shearing occurs. And when we talk about the Mohr circle failure, the plotting the result to determine the peak failure point was achieved, and ensuring the completeness of the test through the Mohr circle visualization help in developing the better understanding of the test results. As we see in the interpolation, the complex geotechnical analysis, preparation involves understanding the trends and the behavior. Often the tests are the more question than the answer, requiring the expert analysis. When we recap this section, so we say in a triaxial testing unveils the vital insight into the soil behavior, but the effective interpretation is mind descripting the test result within the context of the material property and the test condition is essential for the accurate geotechnical analysis. So over here, the case study demonstrated the interactive in therapy between the test conditions result and the real world interpolation in the geotechnical engineering. So with this, I will sum up the today's session. The rest of the thing which is left out will be discussed during the next lecture. So what are the outcomes we get from the today lecture. So some of the best thing we understood, like the UU test, CU test, and CD test. So I think so the better understanding of these tests, how the Mohr circle get formed, how the Mohr Coulomb failure envelope get developed, each understood by one and all in a very good manner with a today thoughtful discussion. So some of the question I will left for you before ending the season. The question are what is your step? The question from the first class. Then the detailed procedure of the triaxial test. If it is available, this apparatus is available at your institute, try to perform the test. If not, try to check out the demonstration on the YouTube and some problem you can solve on the today class and try to write the answer of these questions on your notebook. From the next class onwards, we are going to solve the problems related to this topic in the class very often. Some of the reference books are also mentioned over here for your help. You can go across these and found the problem from these books. And with this, I will sum up this session. Thank you everyone for attending the session. And I'm sorry. Thank you everyone for attending this session. And with this, I will end up the today's session. And thank you everyone who are over here. Wish you a very happy weekend. Thank you. I will sum up the session. Thank you everyone.